Hi, I'm Peter Fijn from the Edge Software Consultancy, and today I want to show you how to do nonlinear curve fits in Morphit. So you're looking now at our company website www.edgeka.com, where you can get information on Morphit and also download a 30 days free trial. So let's close this window and let's launch Morphit. So this is launching Morphit version 4.0. I will try to record this session in one go for you to judge how easy it is to do curve fits in Morphit. So the first thing to do is create a new data table and then add a field header which is called X. So these are your known data values. So this can be 1, 3 and 10 for instance. We can also add some records, make that 30 and 100. So this is an exponential series. And then we can create a new group level and a field header called Y. And the reason for doing it this way is that we can have multiple replicates of Y values per X value. And this is a typical situation where you do multiple measurements and you just want the curve fit to work on them all. So let's enter manually some data here. And it's not so important what we enter. I'm just dreaming up some random values. So for, let's make this 8, 7 and 8, or 7 and then 10, 11 and 8. So it gradually goes up, and this is all we require for a curve fit and to demo it to you. Of course, this can also come from other applications by pasting it into these columns, and also we can link it to text or Excel files or any other type of file, and we can read it straight in through Morphit's internal modules. But in this case, it's just manually entered data. So let's rename this group to replicates. That makes more sense. And then let's also rename the X and the Y, because what I'm going to show you is a curve fit that is applied to a biological in vitro screen where we do concentration versus activity curve fitting. So we will rename X to concentrations. So this is the concentration of a drug, for instance. And here we have the Y, and we rename that to activity. Oh, I see that I make a typo here. Not that important, but concentration. There we are. So now we've got our biological data, and now we want to do a curve fit on those data. So to do that, in order to do that, we stand on the headers and we push it down one level, so that now we get room for a fit field. So this is the new field that we obtained, and we call that fit. And we push it to the right. So now we get our data and then the fit. So this makes more sense to do it this way. And now we will tell Morphit that the field that we just called fit, we turn it into a special type of cell called a curve fit cell. Curve fit. We select the curve fit here from the toolbox, and then we click on the header of the cell of the field, and now we have turned it into a fit field. It says insufficient data because it has no idea where the data comes from. So by double clicking on the header, we can just open a wizard and we point the x-axis to the concentration and the y-axis to the activity. There we are, and we give it a name. We call it a fit, for instance, and here we can set which curve to apply. So we have now chosen a sigmoidal model. If you want to know the details, so here you see the parameters that come out of the sigmoidal model. If you want to know the precise details of the equation, then you can just go to the help system, file, help, and then we request fitting for Morphit help, and then we can search for sigmoidal listed topics, and here you get a full explanation of the sigmoidal model. So this is the equation that is being fitted. Yes, so it's a nonlinear equation with the min, the max, the log EC50 and the Hill coefficient as output parameters. So the steepness of the curve, so here's an explanation of all these parameters. So let's close that. And the fit is now poor. And the reason for that is that concentration is now going in linearly. And this particular model requires that we first do a transformation on the x-axis, and the transformation is a log transformation, a 10 log. So if we now click OK, you see that the fit is pretty good, and it's 93%. And this value is equal to the r squared of the fit. So that is telling you about the proportion of explained variance, so all the variance in the data, and 93% of the variance is explained by your mathematical model. So this is all great, but we can't see anything else. We only see that the fit has been successful. So let's add some visual feedback. So we stand on fit and we just insert a new field. And this field is going to be called the chart. So we get some charting in this field. So we need to tell Morphit that this is a chart. So we select from the toolbox the chart, we click on the field, and there it opens the wizard. And we tell Morphit that we are going to plot concentration on the x-axis, and we are going to plot activity on the y-axis, and then we turn it into a point type of graph, and let's change the crosses to little circles, so we reduce the size of these dots. So we now got a concentration versus of the activity versus concentration plot. But as you see, concentration is still on a linear scale, and like in the fit, we need to plot that on a logarithmic scale. So let's do that. We select the axis properties, then we make the x-axis into a numeric type, and we change logarithmic transformation log base 10. So this is now plotting nicely our activities for each of the concentrations we entered. So the thing to add now is the fit to the chart. So we want to know how close the fit is to our data points. So we open it again and we go to the series tab, and let's call this the original series, we call it data, and now we are adding a second series and we call that the fit. And that is of the type curve fit, and by doing that Morphit understands that all it needs is a fit cell. So that is a pointer to this fit cell. So we click on it, we click on this fit cell, and that's enough to tell Morphit what it needs. So it plots in one go the fit line. That was a preview, and here you see the actual result, and you see that the fit is nicely going through the data. So if we now change the data, for instance we make this 14, you will see that the curve fit changes with it. So let's move it back to 10, for instance. Right, there we are. The next thing to do is to extract the parameters from the curve fit, and that is pretty straightforward. So we create 4 additional fields for the 4 parameters of the fit, and we name them accordingly. If you want to know what parameters to use or how they should be named, you can click on the fit and then use the properties here to scroll down a little bit, and here you get all the parameters that can be extracted from the current settings of the fit cell. So that is the Hill, the log EC50, the max and the min. And of course you also get the standard errors of all these parameters as numeric values. So let's use this information and just give these fields the same names. So let's call this min, containing the minimum parameter of the fit. We are going to rename this to max. This will be the third parameter, which is the log EC50, and this is going to be the slope or the Hill coefficient. Let's call it Hill. And now all we need to do is use the formula bar to take out the values from this cell and pump it into these numeric fields. So that works as follows. We start with an equal sign to tell Morphit that this is a formula is, and then we take this fit cell and use a dot to extract the min from it. So here you see that the minimum, so that is this sort of level, it's the minimum level of the curve fit is 0.258. We will reduce the number of decimals a little bit like this, and then the max is done accordingly. So it's the fit dot max. You can either point to the fit cell or you can just type it. This is the fit dot log EC50. And finally we got the hill is fit dot hill. There we are. Reduce the number of decimals again. And there, that's all there is to curve fitting in Morphit. Of course, there are details like the advanced features of the fit. So if we click on it, we can go to the advanced tab, and there you can see that you can increase the number of iterations. You can also change the convergence of the fit. So let's make it a little bit smaller. It will just do more iterations to make sure that the fit will end at the proper minimum r squared. But in this case, there is no difference. So the great thing about Morphit is that we have now applied it to one data series, but we can easily add a new data series by just using Control Insert, and then it opens up. We can just add a new data series 2, 4, and 8, for instance, as concentrations, and then we take out some of the replicate cells, so we get one replicate in this case per concentration. Let's make it 2, 4, and 8 as well. And you see that Morphit is just applying exactly the same rules to this data set as it did to this data set. So these are the parameters taken out, and this can be endless. I mean, there can be 1,000 of these data sets in one go read from file. So we have now set up a very simple binder to do a large amount of work if we want. So this concludes my first video on how to do curve fitting in Morphit, and I thank you very much for listening.